Here are some odd questions in the textbook from 7-4 worked out. There are simply too many techniques to try to go through each individual one during a class lesson, so I'm going to try to hit a bunch of them in one video. Hopefully this will help with your own investigations and your own work outside of class. 49 to the 1/2 power. Remember, the index becomes the denominator. So this is actually just like saying the square root of 49. That's something we know what it is, and that one is 7. Okay, 3 to the 1/4 times 27 to the 1/4. Now these do not have like bases, so we cannot just add the exponents. In this case, let's transform them into radicals, and it's 4th root of 3 times 4th root of 27. Now we can multiply the bases together and put underneath 1/4 root. 3 times 27 is going to be 81, and aha! We know what the 4th root of 81 is. We can do it on our calculator. That's just going to jump out and be 3. Now for these two, we have to simplify these into radical expression forms. So remember, the index is always the denominator, so this is a 5th root. So we write it like that, and you can write the numerator of the fractional exponent two ways. I can write it as y squared all underneath the radical, or I can write it again 5th root and just leave the base under and put the entire thing inside parentheses and take it up to the 2nd power. Each of these are equally correct. It depends on what you're looking for and what the problem says on how to evaluate that when the time comes for an RLP. For this one, 1.2, we have to do a little manipulation. We need to make this a fraction of an exponent. So let's remember, any number can be expressed divided by 1. Now all we have to do is, this is 1.0, right? If I move the decimal point one space to the right for both of these, it becomes 12 over 10, which I can reduce this fraction down to 6 over 5. So this is actually equivalent to y to the 6 over 5 power. And let's do the same thing we did up here. This is a 5th root of y to the 6th, or it's the 5th root of y, all of that taken up to the 6th power. Okay? Number 31. 64 to the 2/3. Let's do the same thing we did up here, but now we have a number to evaluate. So the index is the denominator. So it's the 3rd root of 64 squared, or the 3rd root of 64 quantity squared like that. Well, this one I know what this is. The 3rd root of 64, I can do this in a calculator. That's just 4. So the 3rd root of 64 becomes 4, and we have to square that, so it becomes 16. Oops, not circling all my answers. Okay, now we have a rule where a power to a power, so an exponent in parentheses taken up to another exponent, this exponent distributes and multiplies times all the exponents from each base inside the parentheses. So this one becomes x to the negative 4 over 7 to the 7th power. So we multiply 7 times negative 4 over 7. So negative 4 over 7 times 7, well that's 7 over 1. The 7's cancel, so this is actually x to the negative 4th. We don't want to leave our answer in negative exponents. Remember, the rules of negative exponents is it flips to the bottom, or it just flips, and we express it like that. Okay, let's put all this stuff together. Take negative 32 to the 1/5 power. So negative 32, the index is the denominator. And then we have to do y to the 15th times 1/5. Let's see what this gets us. Is this all on the page? So the 5th root of negative 32, I can plug that into the calculator. That's just negative 2. 15 times 1/5 is y cubed. Boom, it's done. As long as you know the rules, most of the stuff is just simple practice.